Welcome, Hornets, and thank you for joining me. We're going to be taking a look at assignment number 11. This is part 1. In part 1, it is my intention to work on numbers 1 through 23 odds only from page 442. Now, in the first group of problems, please take note, all they want you to do is try to set up the appropriate integral. And we're looking at our upper, which is 0, minus our lower, which is x squared minus 6x. And we're going from 0 to 6. In number 3, you'll notice we now have our y2 equation, which is negative x squared plus 2x plus 3, minus our lower equation, x squared minus 4x plus 3. And we're going from 0 to 3. In number 5, we're working with our cubic first, going from negative 1 to 0, minus the 0, and then we're going to do 0 minus the 3 times x cubed minus x, the quantity, and that's going from 0 to 1. So let's go ahead and do these couple of problems. We're going to start with our first one. That first one, if you recall, if you're looking at your textbook, we are starting at the integration, and we have from 0 to 6, with our upper equation being 0, minus the lower equation, x squared minus 6x dx. Now, I'm going to just simplify this so that it is in a way that I will go ahead and integrate. That's negative x squared plus 6x dx. They do not ask me to integrate. That's important to remember. Number 3. Let's take a look at number 3 again. That was the one that had the two quadratic equations. So we're working with the first quadratic equation minus the second. So y2 minus y1 is the orientation. So in number 3, we are starting from 0 to 3. And I have a negative x squared plus 2x plus 3. And I'm subtracting the x squared minus 4x plus 3 dx. As I did before, I want to simplify this to a point where I can work with it. And you'll notice I'm getting a negative 2x squared. I have a 2x plus 4x makes plus 6x. And the 3's cancel. And that's my answer. Let's go to take a look at number 5. Notice these go fairly quickly. Number 5 had that two-parter. So we have one integral from negative 1 to 0. Then we have a second integral from 0 to 1. We're dealing with y1 minus y2, then y2 minus y1. Let's go ahead and do that now. So we're looking at the first one is the integration from negative 1 to 0. And I have the 3 times x cubed minus x minus 0 dx. And I'm adding to it the integration from 0 to 1. This time, it's now reversed. So I have 0 minus 3 times x cubed minus x dx. And I'm just going to go ahead and simplify this as I did before. Negative 1 to 0, 3 comes out, and I have x cubed minus x dx, plus, and then I'm going to pull out the negative 3, 0 to 1, and once again we have the x cubed minus x dx. And that's my answer for number 5. Now, numbers 7 through 12 is asking us to simply graph these equations and put in the appropriate, or shade in the appropriate region. Okay, so we're just trying to represent it. So here we go. Our first one is the integration from 0 to 4 of a linear equation, x plus 1, that comes first, minus a linear equation that is a half power. So when I graph this, I'm going to go ahead and I'm going to start with that first graph. That's the x plus 1. Kind of looks like that. Then I have the 1/2 x, which goes like this, and you'll notice it continues. So at another point they'll intersect, but we're going from 0 up to 4. And so the area we're trying to find is there. Let's go to number 9. Number 9 gives us a cubic and a linear, similar to what we saw in number 5. We're going to do the linear, then we're going to graph the line with a 1/3 x, and then we're going to shade in our region. Now keep in mind that there is going to be a little bit of a trick here, because as we do this integration, once again we're going from 2 to 3. And we have x cubed over 3 minus x. And I have minus the x over 3 dx. I'm going to draw the entire thing. Again, I'm only looking at a part of it though. And let's just see, so our root 3, positive root 3 and 0 are the intersections. So we know our graph does this. Good enough. We have our intersection here and here. And they want us to find from 2 to 3 so if this is x equals 3, or right here, then the shaded region we want is just that piece right there. So I graph the entire thing only to find that small little piece from 2 to 3. Let's go ahead and go to number 11. Almost done. At least with this section. Number 11 is now a horizontal rectangle, and we have a line and we have a quadratic. Now, for those of you who struggle graphing these, something that you might want to try doing is converting them into into a y equals. For example, for number 11, we know that our y equaling 2 minus x came from the x equals 2 minus y. So I can graph this as opposed to worrying about that piece. The quadratic is just a square root. So I'm drawing my square root first. It's going like this. Then going to draw my linear equation, which cuts along here. And the integral that we want is going from -2, that happens to be this intersection over here, to 1. And that's this intersection right here. So we're going from -2 to 1, and the region we want is right there. Alrighty, this brings us to number 13. Number 13 is asking us to do this problem without doing all of the arithmetic or the calculations behind it. And we're looking at a line and a quadratic with a vertex point at 1, 0. And we're trying to figure out our areas. Now we know the answer is not going to be A, because these are always going to come out as positive areas. So the real issue is at 2, 10, 4, or 8. Now, the way I'm going to do this is I'm actually going to try and graph it a little bit and see what I get. So I have my 13, I'm doing this. I have my graph going up like that, and it cuts and goes up. This point of intersection right here is 3, 4. This point of intersection right here is a 0, 1. And down here we have 1, 0. Now when I look at this, I want to think about it in terms of what I've got, because I know that this is 2, 1. You notice this entire rectangle is what? Length of 2, height of 1, it's 2. But we've cut out portion of it, so it's a little bit greater than 1. I'm going to call it 1.25. Once again, it's an approximate amount. I know right here I have this point, and this point right here is 1, 2. There's another point here, right here, going up. That point is 2, 3. So I've got a small triangle, I've got a rectangle, triangle, and something. Well, I know that this is 1. I know together that this is a half and a half. And so I'm looking at 1, 2, 3, and a fourth. And I'm looking at what's in here. And I can pretty much see that that's not going to exceed about, 1.5. So I'm going to say that the overall area would probably be somewhere around 4.7. And therefore my closest answer is D, and if you recall, D is our choice for 4. So it's not going to be 8, it's not going to be 10, those are far too much. 2 is way too little, and therefore 4 is the only possibility. So D is my answer, and that answer would be 4. Now for number 15, they're asking us to do it in 2 separate ways. They want us to do it in terms of x, and they want us to do it in terms of y. The problem that we have is that we have to graph this function. And if I'm graphing the function, I've got this going along. And I'm going down here from our, -3, and we're going up to 2. So our basic integration that we would have is our upper minus our lower using a representative axis, a representative rectangle, where we have our top equation. This one is our 4 minus y squared y, and our lower equation down here is y minus 2 comma y. We're doing our right minus left. So we're looking at the integration from -3 to 2, and we're doing our right minus left, which is 4 minus y squared, and we are then subtracting y minus 2 dy. When we simplify this, we have -3 to 2, and we're looking at 6 minus y squared dy, which we can immediately get as 6y minus 1/2 y squared minus 1/3 y cubed from -3 to 2. When I put this in, I end up getting 12 minus 2 minus 8/3, and then I'm subtracting -18 minus 9/2 plus 9. And as we continue to simplify this going down, you'll notice we get 12 minus 4 2/3 minus -9 minus 9/2. This is giving me 7 1/3 plus 13 1/2. And as I add these together, I end up getting 81/6 plus 44/6 is equal to 125/6 for my answer. Now you'll notice this was pretty straightforward. The problem happens in the next part when we're trying to do B, because we now have to find that point of intersection that was clearly visible in the previous part. So we're now cutting across like this again. Graph goes around. We need this point, that point, and we already know this one. So this is 4, 0. This one is at 0, and we're looking at -5. So we have the integration of -5 to 0, and we have our linear equation, which was the x plus 2, as we simplified it. The problem is this one is a negative square root of 4 minus x. This is the positive square root of 4 minus x. And we have to figure that out ahead of time. So this is giving us plus square root 4 minus x dx, and we're adding to it 0 up to 4, and we now have 2 of these square root 4 minus x's dx. Now you'll notice this is a lot more work, and as we go through, we end up having 1/2 x squared plus 2x minus 2/3 times 4 minus x to the 3/2 power from -5 to 0. And then we are adding -2 times 2/3. We have 4 minus x to the 3/2 power, and we're going from 0 to 4. We're now going to plug it in, and we get -16/3. We're adding to it 31/2. We then do the second piece, which is 2 times, and let's call this 0 minus -16/3. So I end up having 61/6 plus 32/3, and we'll have to get a common denominator. And I now have 61/6 plus 64/6, and this is giving me 125/6, which was the answer that we had before. Now, what you'll notice is that this part A was a heck of a lot easier than part B because everything was already there. It was just a matter of going through and finding it. This was harder because I had to relate this square root of 4 minus x, which was the top, minus the bottom, which was the negative, and it gave me the double negative. That double negative made 2, and we still have this piece over on the other side. It's much, much more difficult. All righty, and then they say in general, which method will work better? Well, whenever you have a change in orientation, the other one is going to work. So the vertical rectangle is not nearly as useful as the horizontal rectangle is, because I can do it in one integration. Every time we have to break something up into more integrations, it by its very nature is going to become harder. So please keep that in mind. Let's now go to number 17. Number 17 is working with y equals x squared minus 1, y equals -x plus 2, and we are going from x equaling 0 to x equaling 1. So let's go ahead and just graph this. We have our quadratic, which is going down below, goes up, looks like that. And then we have our x plus 2. Looks like it's going to go, well, something like this. And we're going to have to find all of our intersections between the two, and we're going to do our upper and lower. But we're going from 0 to 1. 0 to 1. Now, I believe 1 is going to put it right here. So this is what we're looking for. And that's what I'm going to work with. 0 to 1. I have my integration, and I'm doing my upper equation minus my lower, -x plus 2 minus the lower equation, x squared minus 1 dx. And this is giving my integration. And I'm just going to go ahead and simplify this so that I have 3 minus x squared dx. And that's what I'm now going to integrate. 3x minus 1/2 x squared minus 1/3 x cubed from 0 to 1. And as I do this, I have 3 minus 1/2 minus 1/3. The 0 causes everything to go away, so I have 18 sixths minus 3 sixths minus 2 sixths, and this is now giving me 13 sixths, which is the same as 2 and 1/6. And there is my answer for number 17. Now that leaves numbers 19, 21, and 23. I'm going to leave those for you to do on your own and give them a try. And I hope this has helped. This is only part 1. Keep that in mind. Tomorrow I will be doing 31 through 41 odds, and it'll give people the opportunity to come in and ask about numbers 19, 21, and 23 if you had problems. Thank you very much. I hope this has helped. If you liked it, please click like. If not, please give me suggestions on how I can improve. Thank you very much, and have a very good evening, and take care, and we will see you all in the future. Bye-bye, Hornets.